Our work explores tangible 3D interactions where there is a direct and perceptual correspondence between what the user is holding and the intended outcomes on virtual 3D elements. To explore this idea, we take an application-based approach. Here, we present ProtoTAI, a multimodal system that helps novice designers express creative ideas as planar shape abstractions. The implementation of ProtoTAI draws inspiration from continuous interaction spaces, where pen-based drawing is used for creating planar shapes and mid-air inputs for 3D assembly. During 3D interactions, the proxy serves as a physical embodiment of planar shapes, providing users with direct control over the modeling elements. This system comprises of 4 components: a pen and touch-sensitive tablet for 2D drawing and central computation power, a planar shape proxy for 3D interactions, a depth-sensing camera to track the proxy's mid-air motion, and a flat-screen display to render the virtual modeling scene. Planar shapes can be drawn on the tablet as freeform curves, polygons, or circles. By moving the shapes around the canvas, relative proportions between them can be compared and adjusted. Users can directly draw over their profile to modify these shapes. Symmetric shapes can also be created by mirroring curves about a line. The 3D scene is displayed in a perspective view and consists of a horizontal floor over which the drawn shapes are laid out. Inside this scene, a planar cursor embodies the proxy and is used as a medium for 3D interactions. The assembly operations can be performed by coordinating the hover state of the cursor with multi-touch gestures on the tablet. For this, we use asymmetric bimanual interactions where the dominant hand manipulates the proxy and the non-dominant hand provides touch inputs. To construct a 3D assembly, users can pick up multiple copies of the shapes and spatially configure them. The assembly can be rotated to adjust the viewing direction. When 2 shapes intersect in the assembly, they are automatically constrained to be orthogonal. By constraining the motion of shapes, users can also arrange them in a pattern along a straight line or the contour of another shape. They can also create a blended pattern by first configuring the end shapes and using a blend menu on the tablet to indicate number of intermediary sections. When the profile of a shape is modified, the changes are reflected in its assembly counterparts. The adjoining neighbors of the modified shapes are automatically reconfigured to accommodate the change. The following video illustrates a complete modeling process carried out in ProtoTAI. The planar shapes of an assembly are automatically fitted with slit joints and can be fabricated using a laser cutter. We conducted 3 user studies to evaluate our work. The results of our first study showed that the planar proxy enabled efficient manipulation and configuration of 3D shapes within a reasonable tolerance for accuracy. Users could also adequately manipulate shapes along a constrained path. Our second study compared key differences between ProtoTAI and flat-fit fab within the context of planar shape assembly. We found that despite the separation of drawing and assembly in ProtoTAI, users could construct the assemblies within similar timeframes While most users found it easier to follow the 2D drawing and assembly workflow in ProtoTAI, they also appreciated greater 3D controllability in FlatFit Fab. The third study focused on the usability of ProtoTAI towards creative expression of design ideas. We observed that with only 15 minutes of training, participants could quickly express a wide variety of creative ideas and diverse 3D forms. Please refer to the paper for details.